Now that we've done basic derivatives, we're ready to move on to these harder rules. And basic doesn't mean that it's easy, by the way. Basic just means it's a short answer. It's not intuitive to know that the derivative of 5 to the x is going to be ln of 5 times 5 to the x. That's not why it's called basic, is because it's supposed to be intuitive or easy or anything like that. It just means it's a shorter answer. These answers are going to be longer, but that also doesn't mean that they're harder. If you know basic derivatives, these rules are going to be not bad at all. If you're struggling with the basic derivatives, make sure that you finish that homework before even starting this. And you can also look at the practice tests and work some of those practice test problems, because these are going to be impossible if you don't know the basic derivatives, but pretty simple if you do. So our first longer rule is the product rule. And one thing to help me remember this long rule is product is always plus. There's always going to be a plus in our answer. And so our function is going to be something like y equals f of x times g of x. And our derivative is going to be a longer one, and it's going to have a plus in it. It's going to be the derivative of the first factor times the original second factor. So f prime of x times the original g of x. Product is always plus. Now I do the derivative of the other one. So g prime of x times the original first, f of x. So you have a derivative times an original plus a derivative times an original. That's the product rule. Derivative of the first, original second, plus derivative of the second, original first. One thing that we want to be clear of, because I do get this question every semester, is how do you know when you have to use the product rule? So if we're going to use the product rule, so one thing that is not a product rule is y equals 5x squared. That is not a product rule. Bring down the power and you get 10x for the derivative. So that's not a product rule, whereas something like y equals 5x squared e to the x is. So what's not a product rule is if there's just one x. If there's two x's multiplied, it is a product rule. 2x terms that are multiplied is a product rule. 2x terms that are multiplied versus just 5x squared is not. It only has one x in it. It's just the constant multiple rule. All right, so let's use that on this h of x. We have 3x plus 2, there's an x term, multiplied by 5x minus 1, another x term. Two x terms that are multiplied are going to be a product rule. And I might just label these ones first and second. That's how I say the rule, instead of f of x and g of x. Either way is totally fine though. So my derivative is going to be the derivative of the first. Derivative of 3x plus 2 is 3. Derivative of the first, original second, 5x minus 1. Product is always plus. Now do the derivative of the second term. 5x minus 1 has a derivative of just 5 times the original first is 3x plus 2. This is one where you could have used algebra to multiply these out, combine like terms, and then take the derivative. It would have taken a lot longer, but you could have gotten to the same place. The product rule is going to be a nice shortcut. Derivative of the first, original second, plus derivative of the second times the original first. Okay, let's look at the next one. Is it a product rule? We have x to the 8th plus 5x. There's one x factor. And then we have this second term also has x's in it. So we have x's multiplied by x's. We're going to do the product rule. We have our first and our second factor. So we're going to call this one g prime of x. Derivative of the first factor, x to the 8th plus 5x. X to the 8th has a derivative of 8x to the 7th. Derivative of 5x is 5. There's the derivative of our first factor. It's more than one term this time, so it needs parentheses. Kind of like what we talked about when we talked about rules 6 and 8 of the basic derivatives. If it's more than one term in the derivative, it needs parentheses. And it's never wrong to have extras. So you could go back and put parentheses on every term of that first one. It's never wrong to have too many parentheses. It's wrong to not have them if you need them though. Derivative of the first, original second. X cubed minus 6x plus 1. Derivative of the first, original second, plus for product, the derivative of the second, derivative of x cubed is 3x squared, derivative of negative 6x is negative 6, derivative of 1 is 0. So there's derivative of the first, original second, plus the derivative of the second times the original first, x to the 8th plus 5x. So you've seen a couple examples now. You are welcome to pause this video and see if you can get all of the remaining ones, or at least some of them. I'm going to keep working my way down and seeing if I have a product rule. So this one, 5x times e to the x. 5x is my first factor, e to the x is my second. So I'm going to call it y prime. Derivative of 5x is 5. Derivative of the first, original second is e to the x. Derivative of the first, original second, plus always for product rule, derivative of e to the x is e to the x times the original first is 5x. Now, none of these are more than one term, so none of them need parentheses. It's okay to always put them in, though. Derivative of the first, original second, plus derivative of the second times the original first. Fine, with or without parentheses on that one. Okay. So this next one, ooh, this is tricky, because I have a rule 6 in here. I have x cubed, and then that's multiplied by e to the x to the 9th minus 2. So I have that rule 6 where I'm going to take the derivative of the power times e to the original power. So this is a harder product rule just because I have more basic derivative rules sprinkled in there. So h prime of x is going to be derivative of x cubed, which is 3x squared. Derivative of my first, and I'll just put parentheses around it all the time just so that I'm not missing them. Derivative of the first, original second is e to the x to the 9th minus 2. Derivative of the first, original second, plus always the derivative of the second. Now I have to use rule 6. Derivative of my power, x to the 9th, is 9x to the 8th. Derivative of minus 2 is just 0. So there's the whole derivative of the power times e to the original power. So there is my whole derivative of the second where I used rule 6 times the original first is x cubed. Man, these are long rules. Derivative of the first, original second, plus the derivative of the second times the original first. We're good to go. This next one's a bit more manageable, but sprinkling in our rule 9 here. I'm just writing these down. You don't have to memorize the numbers of the rules at all. I think it's already hard enough to know all these rules, but just in case you're like, I don't remember that, you can look back at the rule 9 examples. That's the only reason why I'm writing it. The derivative of f is going to be labeled f prime, and I have x times ln of x. So it almost doesn't look like a product rule just because it's so small, but it is. You have x term times an x term. So I'm going to do the derivative of the first factor first. Derivative of 1x is 1. Derivative of the first times the original second, plus always for product rule. Derivative of the second, what was the derivative of the natural log of x? It's always 1 over x times the original first is an x. And again, you can put parentheses if you want them. Derivative of the first, original second, plus always, and I might do it here just because it looks weird to not have parentheses around a fraction. Derivative of the second times the original first. You technically don't need parentheses anywhere on that one though. All right. Our last product rule, the hardest, just because I have a couple of the harder derivative rules in here. So 7 to the x, that was rule 7. And then ln of something besides a regular x, that was our rule 10. Again, you don't have to memorize rules. It just makes it easier to reference back in your notes, especially when you go to study for that cumulative final and you're like, what was I thinking on rule 6? Or example 6, then you can go back and look at those rules for the individual pieces. So 7 to the x is my first factor. And then my second factor is ln of 6x plus 10. So derivative of my first, derivative of 7 to the x is ln of 7 times 7 to the x. I warned y'all, it's hard if you don't know your basic derivative rules, but it's okay if you don't know a couple of these. As long as you've mastered most of them, then these shouldn't be too bad. Derivative of the first times the original second, ln of 6x plus 10. Derivative of the first, original second, product is always plus derivative of the second. This is our rule 10. It's the derivative of the inside over the original inside. So 6x plus 10 on the bottom, and then my original inside derivative of 6x plus 10 is just 6. So am I done? No. Derivative of the first, original second, plus always for product, derivative of the second, times that original first. 7 to the x with or without parentheses because it's just one term. I'll throw them in just for funsies. There is as hard as the product rule could possibly get.